Welcome everyone, and thank you for joining us today. My name is Ashley Soa, and I'm a User Services Librarian for McGraw-Hill, and I'll be facilitating this webinar today with our special guest, Dr. Jim Stone. Just a few housekeeping things before we get started. All of the lines have been muted, so please use the Q&A box on the bottom of your screen to type in any questions that you have. If you're having any technical issues, we can help troubleshoot through that Q&A, and that's also where you can enter any questions that you have for Dr. Stone for our Q&A portion of the presentation. And I'll be monitoring that, so you can enter your questions at any time during the presentation, and I'll be sure that those are passed along. This presentation is brought to you by McGraw-Hill's Access Engineering, which is an engineering reference platform. Some of you may be familiar with McGraw-Hill's Connect platform, so I just wanted to take a quick moment to describe the difference there. So Connect is purchased at the course level by professors, paid for by students, and is on a title-by-title basis covering our introductory textbooks. Access Engineering is purchased at the institutional level by your library, and then all of the content on the site is available at no additional cost to faculty and students. And that content includes reference titles, handbooks, upper-level textbooks, as well as instructional videos, spreadsheet calculators, interactive graphs, and a lot more. During the current COVID-19 crisis, we are offering free institutional access to Access Engineering, and if you're interested in checking if your institution has access, want to set up that access, you can again use that Q&A box, and we'll follow up with you on that. And if you're interested in seeing more of the Access Engineering platform and what it offers, I will also be hosting an informational webinar on that next week, and we'll send out a link to register for that in the follow-up with the recording from today's session. So again, this session will be recorded, and everyone who's here today and who registered will receive a recording. I also want to note we'll try to get to as many questions as possible, but there is a very large audience today, so if there's anything we don't get to or that requires a more detailed answer, we will follow up with those folks after the webinar, so don't worry if we don't get to your question, it will still definitely get answered. And now on to the presentation. I am thrilled to introduce our guest speaker, Dr. Jim Stone, who is a professor of environmental engineering in the Department of Civil and Environmental Engineering at South Dakota School of Mines and Technology. He joined SD Mines after completing his PhD in environmental engineering at Penn State, and he also completed his Bachelor of Science in Civil Engineering and Master of Science in Environmental Engineering from Virginia Tech. Between his studies at Virginia Tech and Penn State, he was an environmental consultant for 5 years, where he designed environmental remediation systems for water, wastewater, and hazardous waste applications. His research interests have focused on a variety of collaborative and interdisciplinary projects focusing on sustainability in the environment, including life cycle assessment applications focused towards agricultural and environmental engineering processes, and fate and transport of contaminants from historical mine sites. In the classroom, he has taught a wide range of core and specialty environmental and sustainable engineering courses and integrates active and problem-based learning approaches into all of his classes. Welcome and thank you for being with us, Jim, and I'll let you take it from here.
Thank you, Ashley. Thanks for the introduction. Let me get my screen shared here. So again, I'm Jim Stone here at the South Dakota School of Mines. I'm here in snowy western South Dakota in the Black Hills out in this area. So hope all of you are doing well, keeping safe, and it's crazy times in academia. So what I'm going to talk about today is looking at how we do engineering, or how I do engineering exams in a open book, open notes, open computer classroom. And I think all of us are going to be experiencing this here shortly as we move forward to our final exams. So as an outline, I'm going to talk about the tablet PC program we have here at the South Dakota School of Mines, kind of my history of what I've been doing, and then kind of run through some typical exams questions that I've been using for some environmental engineering courses here at South Dakota Mines, look at the student electronic submissions, the use of access engineering as the students kind of access this material and solve problems, and then how we administer this remotely. So again, this is Jim Stone. This would be me if I was allowed to go into my office here at the School of Mines, but I can't do that right now. But I was kind of brought up with traditional teaching mechanisms at Virginia Tech and Penn State, you know, the kind of talk and chalk that many of you or many of us have kind of gone through over, you know, as we came through our degrees and kind of moved forward with that. And I've kind of pivoted and changed a lot of things that I do in the classroom as a result of what I think the students really need and how we teach engineers of tomorrow. Here at the South Dakota Mines, we have a tablet PC program where all incoming freshmen are administered or given or paid for a tablet PC that's kind of like this, and you can write on the screen, you can follow along. All the software is loaded onto these computers at that particular time, and we use them in the classroom extensively. That's part of what we do here at South Dakota Mines. And I've kind of embraced that as my model, and we kind of learn by doing and do a lot of things that are here with these computers. And so, and a lot of my exams are doing the same thing as we use these. And it's been a wonderful addition. We've had it about 12 years here at South Dakota Mines, and it's been phenomenal in the classroom. And so I use a traditional course management here, our South Dakota Board or Regents. We have Desire to Learn, or D2L, and I'm sure many of you have a similar type of course management software that you're using. And I administer my exams using this, and I'll kind of walk through a demo if I've got time later. But essentially using quizzes, and you can kind of post them on there. But this is current as of yesterday, I think, what's going on in one of my classes, my Intro to Environmental 2 course that I'm teaching here this semester. So I do a lot of active learning, and I've kind of modeled this and done a lot of things related to active learning and looking at, how we communicate and do things in the classroom. And so I typically give incomplete PowerPoints in the classroom, and the students follow along using their tablets, either through OneNote or directly writing on PowerPoints, and kind of follow along and do things as we go through this, and have a lot of active learning exercises, whether they're discussion forums, surveys, or pollings that are there. We've got some online web searches and web searches using the tablets, and then also in-class assignments. Lauren, do you want to jump in? That looks like there's a question there. So if you're not seeing the presentation, you might want to try maybe a different browser, is I think what I'm hearing. So go ahead, Lauren.
I think the suggestion seems to be Chrome and Firefox works the best. I don't know if if there's any other suggestions, but I know we're just seeing a lot of Q&A that people are having trouble seeing the presentation.
Okay.
Yep, so Chrome or Firefox is recommended, and then also if you want to use that restore button at the top, that should help at the top of the screen. And again, you can keep putting your specific questions in, and the webcast engineer will be helping with those.
Perfect. All right. So we've got, and we also do a whole bunch of in-class assignments as well, where the students will work together in small teams and then load information onto a Dropbox and put their files in there to get credit. This is kind of an example of what I do for some in-class work that we're doing. This is an incomplete PowerPoint. Here's a homework problem that they're working on together. They've got the burning newsprints, and they've got I'll kind of write in with my pen of what needs to be done in here. And then they'll work with their neighbors, and I'll provide their answers in some sort of lecture survey, which is like a clicker that a lot of universities use. And that's a good way of tracking this. And so it's kind of active there. Here's another one where I looked at my personal car fleet calculation. This was something we did right before spring break, or when all the COVID-19 things came together and closed the campus, and looked at my electric car, my Prius, my camper van, and then their car, and kind of calculated these things and the fuel efficiencies, miles per gallons, the emissions that are coming off of here, and then perhaps the gallons of water consumed. And they work together to answer these questions and then put them in an in-class discussion forum, and kind of talked about what the best car was for that particular, or for the environment, and why. And so it's kind of the way my classes go. And so when we get to midterm and final exams, I like to give them as much information as possible to be successful in the class. And so I usually give them about a week out. I give them some kind of a Word document posted on D2L that kind of summarizes what the exam's going to be, all the topics that are there, time that's there, the format, open book, open notes, open computer, short answer, discussion, problem solving, and then some basic things. Make sure your computer's fully charged, bring your power cable in, and they're able to use just about anything. As long as I can open it, they can submit whatever that may be. and no paper. I haven't submitted any paper in probably 7 or 8 years now at the School of Mines. And then to kind of walk through, and here's kind of all the topics laid out there. And so what I've seen students do is kind of walk through and, you know, put check boxes on there and try to figure out, you know, go back into their notes that they have and see what we covered there, and set up essentially their command center or mission control. You know, so anytime you take an exam that's open book, open notes, it can be quite overwhelming. So make sure your notes are all organized correctly. Make sure all your information on PowerPoint or OneNote is there. And also tell them to set up some quick links, perhaps to Access Engineering and maybe some other internet sites as well, and make sure that information is available there. And that could be videos, spreadsheets, things like that. So they kind of set up these command centers so when they come into the exam, they're ready to go and not spending a lot of time. So here's, you know, one of the classes I'm teaching this semester is using Access Engineering, and we've got our textbook is there, so Water and Wastewater Engineering by Davis. And this looks like it's from ion exchange treatment processes, but I tell them to kind of set up links for the specific topics that we've covered in the class so they can quickly navigate to that if needed during the exam. So they're not spending all their time looking for the information, but they kind of know what it is, but they can search for things to verify what it may be as they go through this. So, and then we also have on here, we have this set up with, at the end here is what they're going to see in the D2L text header that's there. So this is what's going to be showing up on the exam. And so this is, I guess I'm looking into the future with fall 2020, but it's going to be open book, open notes, finished by this certain amount of time. Then you can load the files. There's no limit to what files you're going to put into there, but you can upload multiple files and put them in there and make sure they're just annotated so I know where they are. And then also on the Dropbox text as well, here's what they can put on there. So they already see what they're going to have or what they're going to experience. And this is definitely critical for some of the junior and sophomore level courses that I haven't seen them in class before. And then I also give them a practice exam so they can practice and see what the interface looks like as they go through this. And so here's the header that we would have for the exam, how it's done, and here's just an example problem. This one, they would have to answer something, so they click on this, submit the quiz. Other times, I give them specific instructions to take your work and put it into some sort of Dropbox that we have on our course management software. And so some things that are critical, especially as we move into more distance online learning. The first question that I've done before is kind of the academic integrity content. So I put a paragraph similar to this as the first question on my exam. And it says, it doesn't, so you can't talk with others. This is your own work. You can certainly look up things if you'd like, but you didn't collaborate with either current or former students as you go through this. And so it's, and then there's a penalty obviously associated with that as well. And so they would submit this. That's maybe question one of whatever questions you would have in this, this exam. So here's kind of what we did pre-COVID-19. We were in the classrooms. Here's kind of the students have their command center set up, got their tablet PCs. I like to teach in classes that have a little more desk space than what we have right here, but they've got their textbooks there. They've got their, a lot of them are wearing headphones, listening to music, or a lot of times they're listening to my videos on Access Engineering as they're walking through or on my YouTube page. Some students bring in supplementary monitors there, although it doesn't look like it's being used for too much, but you can kind of see what they're doing and how they're going through solving this, and kind of deeply focused here. And then, of course, sometimes Windows might not work too well, and you might get these, these blue screens, the dreaded blue screen, but I think there was a big rash of this last spring when Microsoft was doing a lot of updates, but it can certainly in fact, I give students a lot of flexibility to stay longer. You can come back to it and do it later if need be. But you can kind of see the setup of how they're doing this with our tablet PCs. And these kind of fold over as well. You can write on the screen and go through with that. So my exam formats. So my formats are usually a mixture of many different things. I think the best exams are those that have a lot of different modes or mediums or things for them to work on, instead of just regurgitating problems and doing real or formulas and doing very simple things. I like to kind of have a broad array of things to look at how deeply or how much they know with this particular topic. And so it may be related to discussions, multiple choice, I do a lot of computational solve, and also perhaps using some model simulations or calculations that we've done before in the class, and then follow up with maybe changing some parameters, some sort of sensitivity analysis, and then coming up with explanations of how or why that might occur. And maybe they just use screenshots using Windows Snippet Tool or something, and then they just post that onto D2L with some sort of discussion. Now, over these years, I've kind of walked around. I do monitor what's going on to see what the students are looking at in there. And, a lot of times, at least the screens that I've seen as I walk around, I usually get up every 5 minutes and just kind of pace around and just kind of randomly look at screens and see what they're doing. Usually they're sifting through their course notes. They're just actively kind of going through, looking at their OneNote or PowerPoint slides and kind of maybe looking at last semester's PowerPoint slides from my Intro to Environmental Engineering 1 course. They're answering the questions in their medium, whatever that may be in Word, Excel, MathCAD, OneNote. It could be something like that. Obviously doing a whole lot of Google searches and trying to find some information that might be there. Reviewing the digital textbooks, so they're kind of sifting through that, doing some keyword scans or searches, searching on Access Engineering perhaps for some computational methods or spreadsheets or videos. And then interestingly enough, a lot of watching videos. They get their headsets on, just kind of following through, and I don't mind that at all, because it's going to be a different problem, but they're actually applying the information that they've been learning in the class, which I think is wonderful. I mean, this is essentially what they're going to be doing in the job market as they leave academia, and so here they're applying that information and kind of, this is the next step of learning, is seeing how that works. So classes that I've taught using this format, and this is something I've been doing probably the past 3 years with the incomplete lecture notes and whatnot, and I kind of picked this up in some ways when I had a sabbatical in University of Canterbury in Christchurch, New Zealand, and I came back and I kind of reinvented a lot of the courses that I do. I was kind of heavy into research, and I kind of pivoted a little bit here to try to get better in the classroom, but also be better in the research field as well. And so I've taught these classes. The ones that I've got highlighted here in yellow are the ones that I'm currently teaching in the spring 2020 term. I got the Environmental Engineering 1 and 2, and we're using the Masters in ELA textbook, a little old, but it still is quite good. And then for some other classes here, we've got drinking water treatment, advanced drinking water treatment, and wastewater treatment. And that's using the Davis textbook, Water and Wastewater Engineering, 3rd edition, and that is completely available on Access Engineering. And I've also taught some environmental chemistry courses, or this course in particular, and that's using the Sawyer, McCarthy, and Parkins Chemistry for Environmental Engineering and Sciences. And so what I'm going to do is kind of walk through some types of problems that I've used for these, specifically for these classes I've got highlighted in yellow for this semester. So you can kind of see what's there and what I do. And so this would be a common one. This is, I usually set these up on Word, and then I copy and paste the problem statements and things onto our course management software, set it up as quizzes, and this would be one, it's essentially a treatability study looking to something, some hazardous chemical that's here, and so I'm asking, please plot this data and answer the following. So they have to actively do something in the exam. And so they've got to open up Excel. They've got to set this up, open it up in Excel, plot this data, and then answer these questions that are down here. And they're typically going to do this on Excel, maybe MathCAD as well. So create a graph, and I tell them specifically what the axes are, and then is this a zero first order reaction with the rate constant, all these things they have to do with this. At the bottom of every problem, I tell them where they need to post it, whether it's going to be saved onto the quiz itself or put it into some sort of spreadsheet medium that's there. And this is kind of what the problem or the solution, a one student solution is. And we do work on this quite a bit with organization, especially in Excel and MathCAD and Word and whatnot. Just make sure you highlight the solutions that I'm looking for, make sure the work is all neat and orderly, and so they have time during the exam to do this in here. And so we've got, here's the plot. You can see this, and then they had to go in and do some additional work here, kind of linearize it, and then they have some answers that are down here at the bottom of what they have. And so this would be the type of work that I see in the drop boxes for the students. Other ones here, so a lot of things I'll do as well is I will revisit homework problems that we've collectively solved in class. Maybe we set up some sort of Excel or MathCAD model with a lot of different computations. That's very common in what I do. This is a Streeter-Phelps DO sag curve that looks at dissolved oxygen as a function of distance and temperature and things like that. But there's a lot of calculations that go into this, and we spent a good part of the class period, if not more, in a homework problem solving this. They already have this model built. Now they have to use it on the exam, which is great. And so they've got here, I just changed one parameter here and changed one parameter here, and then they've got to do this. If they had to build this from scratch, it's certainly going to take a long time. But if they've got a model already built, which most of them do, if not all of them, they should, then they can easily go in and make some changes. And so this is what the solutions would look like. The challenge with Excel, as we all know, is that a lot of the formulas are embedded in these equations that are up here, but you can still sort through those and kind of check where errors might be. But they copied and pasted the problem statement up here at the top. They can use that with Windows Snippet, paste it on there, and then they've got all the givens. And we spent quite a bit of time building this in the classroom. Now they're just applying it, and so they change some parameters, and they get this DO sag curve that occurs right here, and they can answer the questions that are there. So this is kind of, using what we've done in the classroom and then just making some changes and having them set it up in the exam. And that's something I do quite a bit of. Let's look at another problem here. This was a recent one looking at a landfill. And so, and they could certainly look up this information, but they might not get everything they need to solve this, but they have to essentially draw a cross-sectional diagram of a landfill that's in New Orleans, so high water table and whatnot, subtitled D landfill. And then for each layer within your cross-section, please explain its purpose. And here it looks like I'm saying provide your answers in the Dropbox as well. So this is some work that the students submitted. They might have spent 10 minutes kind of drawing this, and they've probably got their lecture notes that are right there, and they can kind of see some of the cross-sections and the materials that we passed around in class. And then they've just got to draw it, and essentially a closed landfill. But then the key is they could probably find this information online, but then they've got to describe it. And so they've got to describe what each layer does in that process. And so they went in kind of and briefly mentioned what each layer is, what its purpose is, what are kind of the engineering characteristics associated with it. And so it's something where they could, they certainly could look up a cross-sectional thing of a landfill, but they've got to explain it. And that's kind of where they kind of dig into our course materials, and I can gauge as to how deep they understand this kind of the materials that are there. Another one that's got here, so looking at my 2011 Toyota Prius. So I made this kind of personal because we did talk about this in the class a couple weeks prior. And turned out the Toyota Prius was the most efficient car, all things considered, for the environment based upon the parameters that we were looking at. And then it's just a simple calculation that's here. So they've got a fuel tank. It gets this much mileage that's there. They had to look something up in our textbook. So there's some activity they've got to do and find this information either in our textbook or in a PowerPoint slide that I had there. And then answer these simple questions. If I was to put E85 into the tank, well, it probably wouldn't run very far. But if I did, what would be the miles per gallon and the range that I would get with that? And then the types of calculations, the students provide. Here's on the left, it looks like they use Microsoft Word, but most students would use perhaps Excel to solve this. They've got it set up here. You can see all the different steps. And so as an instructor, you can kind of see where their mistakes are and make sure they've got all the bases covered. And then here's a summary of the answers or the solutions that are there. And then here's a MathCAD example. A student submitted this with MathCAD. And MathCAD is wonderful when you have units that are associated with it. You can track the unit to make changes and put in whatever type of units you would like there. And this is, they've got the table that's copied and pasted onto their submission on MathCAD, and then it's easily loaded right there as well. Excuse me. So those are some examples of what we've done with some of my work. We've also got things that where they would put in some sort of, answer to some problem. They'd had some sort of discussion that would be there. And so looking at photochemicaloxidants, and they'd have to, come up with this. A lot of times the students can, search and look this up, and I'm okay with that. They can find this, at least get most of the information online. They're going to put their responses in here. And then this one here, we talked about 6 criteria air pollutants and perhaps talking about the mechanisms of minimizing these or removing these from the atmosphere. So they had to go into the textbook and find out what those 6 criteria pollutants were. And we spent quite a bit of time discussing this in the class. And then kind of thinking about how they can be removed. And so they would put in their answers in a text box right here. And this is something we just did prior to spring break in the class. Another type of example that I do is kind of some pollution simulation modeling or just modeling in general. And we've got this that I got from WPI, and this was a model that they developed there. And we just finished up the Gaussian curve pollution calculations, and we did those on MathCAD and Excel, and then I had the students kind of enter it into this simulation model, and, which is kind of like a black box that's there, and kind of compare the answers. And so we worked with this in class just last week, kind of went through the Gaussian curve calculations, and this is something I'm going to put on my final exam that'll be here in a month's time, where we're going to actually have them do some calculations just like this, and then go in and also run the black box model and compare and contrast and look at what the differences are between these. And so that was kind of neat when we did this in class, and the students would expect to see this later in the semester. And here's the actual problem statement that we did in class, where we did some sensitivity analysis. And did you get the same answer? Explain why or why not. And so you got to explain what those different attributes are in those models that we use. So it's kind of neat as we look into drinking water treatment. These are kind of things that are kind of hard to look up online. You're going to have to go into the textbook and look at our course notes with this. But this is looking at the Freundlich absorption isotherm, for example. And I gave them this graph that I drew up. And we've got an activated carbon here and an activated carbon here. And they've got to go back and look at their notes and kind of answer these questions of what's the differences between activated carbon behavior A and activated carbon behavior B in this particular system. And this is kind of a response that the student did, so you can kind of see the level of the response that's there. That would be a good, certainly an A response for this body of work that's there. But again, they can certainly look up and go onto Google and do absorption capacity, and they might get some information. But this is kind of a way to, get them to think a little deeper about some of the materials we covered in the class and look at the fundamental differences between those. And so that's kind of some common questions that I've given. Another one here, looking at the binary separation factors. This is for ion exchange, and they just had to come up with a relationship difference, or what does it mean between these different alpha values. And this would be kind of a different separation factor that's there. But we spent quite a bit of time talking about these in class, and even during my lectures, I'll highlight this seems like a really good exam material or exam question, and they highlight that. And I just want to make sure that this is something that they've got in their toolbox that they can apply, some of the fundamentals of drinking water treatment. Something that was a little more obscure, but similar to what I've done historically, is kind of more open-ended, more challenging type problem that's here. And this is more applied, but it's using a lot of the materials that we've done in the class. And not to walk through this, it's kind of a complicated problem here, but we've got essentially an ion exchange system for the state of Wyoming with coal bed methane water that has a lot of sodium with it. And I gave them some lab analysis, gave them some flow rates from industry that's out there, and then gave them some discharge that would go into the Powder River in the kind of the central part of Wyoming. And they had to design an ion exchange treatment system for this application and essentially answer these specific questions that I've got right here for the contaminants. And a lot of students did this on Excel. They kind of went through, and we went through a lot of these, or if not all these calculations in the context of my class, but I kind of gave them something that was more applied, something that was more real world, and had them kind of solve that. And so this was just a one problem exam that's there. And this is kind of what the work looked like that the students submitted. They had to determine the flow rates and see what the bypasses might be that would be in this particular system. Calculations, at least on this example, look like they're all embedded inside of Excel here. Kind of a process flow diagram that's here, looking at the bypass and what's going in ion exchange to meet the treatment requirements. And then copy and pasting some information from our course materials, and then answering some questions related, it looks like here, for competitive absorption. You can see the students kind of highlighted the things that are in the water, and they can kind of see where it might be, highlight those, and then came up with a paragraph right here that says what those competitive absorption parameters might be in that application. So that was kind of neat. And then another tab on Excel goes through the calculations, and they determine all the ion exchange parameters and went through the calculations. And we kind of walked through these, or a lot of these calculations, during our class lectures. They already had spreadsheets that were set up, and so now they've got to change and kind of pivot and utilize with new materials and make some changes on their spreadsheets to answer these specific questions. That's kind of how I've done a lot of my open book, open notes exams that are there. And so, yeah, it looks like they answered the questions here. And then one last problem that I've got here is looking at drinking water treatment, for example. And this is, you've got water hardness that's here. You've got this much total hardness, magnesium hardness, and whatnot, and you've got to draw a bar diagram. So that's not something that you can just look up on Google and see solutions, but I'm actually looking for the work that they're doing to calculate, for the calculations they have to do to get that bar diagram that essentially looks at the anions and cations and let's say calcium carbonate hardness, calcium non-carbonate hardness, and so on, and then go through and determine the mass of lime and soda ash that's required to remove this. Now on Access Engineering, they've got a lime soda water softening calculator that's there, and I'm going to do this for my final exam here in a couple weeks. They're going to have a problem similar to this, and then they're going to go in and do the same calculations with this water softening calculator that might better optimize those lime soda ash uses that are there. And this is in the Davis textbook on Access Engineering, and there's a whole bunch of spreadsheet calculators that have been developed throughout Access Engineering. And this is just one example, but the students have this, they can download it. We actually spent some time in the class kind of playing with these and looking at the different calculations or scenarios for basic lime, excess lime, selective calcium removal, and kind of compare and contrast. And so I can develop a problem that would utilize this. And so they got to draw and kind of understand the theory behind it, and then use the black box, let's say, to do the calculations that would be there. And this is essentially what they're going to do in practice anyways. And so what better way to kind of reaffirm that? So the big question is, how do we administer these exams? That's kind of a big challenge, and I think we're all grappling with this as we kind of develop and get through the rest of this spring semester that's here. And so on our campus, we've got a number of different options that we could look at. And one that I've kind of explored a little bit is the Respondus Lockdown Browser. And you can also implement or turn on the Respondus Monitor, and that's currently embedded within our D2L course management software. The one downside with this is that is the browser, and that can be, in a lot of ways, the only thing that they can look at. And so as I promote kind of open book, open notes, open exam problems, I really want them to explore and look around and see what solutions, what things are out there as they kind of answer these questions. And so I feel I'm a little hesitant to limit what they're going to have access to, because in the exams that they normally take, I see them looking at a lot of different things as they walk through this. And so it does work. This was an example of one of our faculty members kind of looking at it, but he was trying to cheat. So he's kind of looking and then goes back, and they look at whether somebody's walking behind here, if he's looking at something else. So that's certainly one option that we could do, or that you could do. The one that I'm kind of leaning towards is looking at a Zoom recording of the student. And so they'll be working at home, and they can set up, all of our School of Mines students have Zoom accounts, and they can record their desktop and have a webcam, and then they would just essentially record it as they're taking the exam. And then essentially you would have save that to the cloud, and then they would just essentially upload that link onto the course management or the D2L work that we have, the Dropbox, and put that in. And so all the work would be there, but in order for me to grade it, I'm going to have a Zoom recording as well. And so I've been playing around with that. So I think the key thing is to kind of set up your expectations nice and clearly, maybe set up an example or a D2L or a Zoom video that kind of explains how the exam is going to be administered, what you can do, what you can't do, and then try to go through that and just make sure everything's clear on there. Seen people also use Microsoft Teams, and so they can use the live chat and do webcam recordings, and you can be available for that. So that can certainly work. And then the last thing is maybe nothing, and just trust and be available and flexible as they go through that. So, and maybe make things just more. I think here at our Board of Regents is kind of moving towards encouraging us to give the students 24 to 48 hours to complete their exams, and they would have to turn it in by the time that final exam period is complete. But you just got to have some flexibility in these trying times as they go through with this and complete things. So I'm kind of leaning towards this right here, looking at the Zoom recording desktop. Again, I've only had midterm, and that was right before our spring break, and then final exams for my 2 courses, but I think many of you in the audience have lots of experience with these, and be curious to hear more about what you're doing. So with that, I think maybe we can open it up now for some questions and some dialogue here. Again, if you have specific questions for me, you can reach me here. And I've got some other problems here as well that I could go through, but maybe we'll stop here and see if we're getting, see if we got any questions that I can answer.
Thanks, Jim. We are getting a lot of questions, so I'll read some out to you now. I've combined a couple questions because it seems like a lot of people have very similar concerns. So first, there's a lot of questions about how long are your exams typically, how many questions per exam, how long do they take students to complete, and are they timed at all?
Yeah, so normally my questions, I usually get about an hour and a half if it's a Tuesday, Thursday class. And sometimes I'll give them 2 hours, a little time ahead of time. If you've got students that have ADA disabilities that need some additional time, I'll give them double the time. But I'm totally flexible. I'm not worried about time. I'm more worried about what they put into it. So usually it can be, and let's just go on to, we can just open up one of my quizzes that I did recently here, if I can find it. Usually it's about 3 or 4 questions would be common, and my midterm exam will be split over 2 days. So I'll give half the exam on, let's say, Tuesday, half the exam on Thursday. And that's kind of how I do it. And this class is a little different. It's only a 50-minute one. But let's just look at, and this was right before spring break when things all went out the window. And so, you know, the quiz, this would be what the quiz looks like, or what the students would see as they walk through that. But this one, I think, was 3 problems. 2 of them were kind of discussion, and then 1 problem was analytical or calculating. Slow connection here, but as it goes through. But
that's okay.
Yeah.
And I'll ask a follow-up question, too, based on that. Are all the students getting the same version of the exam, or do you have different versions with different questions?
Yeah, my classes are kind of small, let's say 30 to 40 students, although my intro to environmental class might have upwards of 80 students in it. But historically, I have given the same version. Unless it's a makeup student that needs to take it at some other period, then I'll make up perhaps a little different version of that. I have played around with sorting the questions. You can have them like question 2 can now be question 1, but I typically just give the same questions that are there. And it looks like this one is the 3 questions that are on here for this midterm exam. This is for like a sophomore junior level course.
Another question that we're getting a lot of is, it seems like people are loving your system here and your detailed questions, but they're concerned about how long it might take you to grade an exam like that. So do you have sort of an estimate of how long it takes you to grade exams, or any tips for grading these types of problems efficiently?
Yeah, so normally I set up my spreadsheet. I usually keep my grades in an Excel file. And then you can, on D2L, you can go in and download all the things into a zip file, let's say on the Dropbox that's there. And you can, from that on the Dropbox, and I just go through and I'll open up all problem 1s, or maybe the student has all their work that's right there. and I've got multiple monitors that are here, and I'll just, provide, answers that would be there, or just give me my grading and put it directly into the spreadsheet. So it does take a while. I mean, grading for anything we do does take quite a bit of time to get through that. But it's I've gotten pretty efficient with doing that, but it's certainly a couple-hour block, if not more, to go through, depending on how many students are in the class. But it certainly does take some time. But it works out well, and I can download it onto the zip file, and then it's all there, and I can just open. I open it on another monitor, and then I kind of walk through. And then what I do also at the end of my exam, after everything's graded, I'll make a Zoom video that kind of walks through the solutions of what it is, and I'll post that onto D2L on the news that's there. And so then the students can watch that video, and if they got more questions, they can come back and follow with me after class or at some other period.
Okay, thanks. That seems really useful. Another question that we're getting a lot of is sort of how do you prevent students from communicating with each other during exams, sharing files, that sort of thing?
Yeah, that's I haven't seen much of that. So if they're on their cell phone, obviously that would be an issue, although a lot of students do. If they're not really handy at writing on the tablets, I do allow periodically for them to write on paper and then essentially take a cell phone picture of it and then make a PDF of that and then load that onto the Dropbox. So that's a way that students do it. But, if I see email open, the one thing I don't want any communication amongst the students that are there. So email and they're chatting between, but I haven't seen it. And I do walk around and look, but certainly in this remote environment, there's certainly going to be the temptation to perhaps communicate with other students that are there. And so that's why I'm hoping, first you got the honor code that's there, but second, perhaps, using that Zoom desktop and web cam that's there, or the respondent's browser might limit those temptations to do that. But, there's no perfect solution to doing that.
Yeah, and along those lines, there were also some questions about maintaining integrity, preventing them from sort of copying and pasting answers in from somewhere that they found online, or if, they need citations for anything that they find somewhere else, or how you handle that.
Yeah, normally the students here are pretty good. They normally, if they find some information, they'll actually include the URL with their submission, and it would be there. So if they found, if they're answering one of these discussion problems, they say, yeah, I found this information here, and here's what we did in class as well. But certainly it's, there's definitely an honor code that we're trying to follow here. And, sometimes we have to trust the students that are here, and they've got to make grown-up decisions. But certainly I've had a couple, you can check if it's a Word file, you can go in and see the origin of that Word file, the history of it. And you can also use, what is that, on that plagiarism check. I forget the name of it now, but you can go on to that and turn that on, the plagiarism check. So if they're going to turn in, let's say, a Word file or PDF, it can actually go in and monitor that and give you kind of a score or analysis associated with that. That's all automated within our course management software.
Okay. There are also some questions. Sorry, reading through and making sure I'm getting all the themes here. There were a few questions about, sorry, I'm trying to find the exact question that I was looking at again. About if you've seen any sort of difference between students, how they perform on your types of exams versus sort of a more traditional exam, if you have any sort of comparison there that, you've seen students react to or you've seen their grades.
Well, so about 3 years ago, when I taught my Intro to Environmental Engineering course, I went back and for one semester did a traditional exam where they had one-page formula sheets and actually wrote it out, just because, I wanted to try something different and see what was, maybe that's a better way, because a lot of our faculty at the School of Mines still do traditional exams and traditional approaches. And so I did it, and the performance on the exams was actually a lot worse. I think the students did a whole lot better when they feel a whole lot more comfortable when they have access to lots of things when it's open book, open notes. I taught the class kind of the same way, and my course evaluations with the paper one were a whole lot worse than with the open book, open notes one for various reasons. I don't know exactly why, but certainly the evaluations, my course evaluations were lower, but also the students' performance was much lower. And I can't really say that it was a worse class. I think it was probably a really good class that was there, but they just kind of struggle, and they trying to consolidate all that in and then just trying to regurgitate what's on their formula sheets. And it just didn't jive with me. It didn't jive with the students as well. And so I went back to my traditional format. And I get a lot of praise from the students for doing this. They just like to learn by doing. And so they actually do things on the exams in my classes.
Okay, thank you. Let me make sure I'm not missing any questions. And Lauren, too, if you see any that I'm missing in here, jump in and let me know.
Yeah, there was one question, Jim, about whether you've looked to see whether any of your questions end up on Chegg, which I guess is probably less of an issue in in-person exams and more of a concern, now.
Yeah, I guess I haven't looked. I should probably set up an account to go on there, but I'm sure some of my former students might certainly be on there. But even if they are, I still change things up quite a bit. I don't know what the turnaround time is on Chegg to get that completed, but the students are going to find a way to kind of address and go through that cheat in one way or another if they really want to. So I've kind of embraced it and just said, just make the exams in such a way that they really got to, plot things and do things and calculate things and show their work as they go through this and use a medium to do that. So, and with that, it's kind of minimized a lot of the cheating that's there. Sure, the students might share files as they go through, but you can kind of track that and see some similarities. But they do a lot of collaborative work together as they develop that homework problem. And so somebody might have already, they work in teams, and so several students might have that same Excel file, and then they got to use that file to do their midterm or final exam question that's there. And for the most part, I haven't had much of an issue. I mean, there's been one or two where I've seen some cheating that's happened, but generally it hasn't been a case.
Yeah, and then there was one person asking whether you spend time in class teaching the students how to use the online tools and software, or do they seem to pick that up pretty easily?
Yeah, most students today are pretty savvy at Word, Excel, PowerPoint. On OneNote, I do spend the first time I see the students, spend a little bit of time showing them how to set it up. I mean, any good faculty member should kind of describe how to best take notes for their class. And that's something I've done all along. And so I get the incomplete PowerPoint, we drag that in, I tell them how to set up OneNote that's in there, and then try to and show them how to set up the pens and kind of write along as we go through that. And this is some examples of our class. If I go in earlier, but of what kind of the board notes look like, and as we go through this, the calculations that are there. And so they for the most part follow along. Our students are pretty computer savvy, and I assume all of your students are fairly computer savvy, and so they really have no issue following along with this format that I've done. I see somebody, turn it in. That's the plagiarism website. So I'm seeing a note right there. Turn it in is what we've got linked onto our D2L.
Yeah, and then just there was one comment from another professor who's used a very similar format to your exams for structural design courses, and he's gone 100% to that format for the online remote courses this semester, and giving the longer time periods to hand it in, and he's been very happy with how it's working.
That's good. Yeah, again, I haven't given an exam yet. I've given some quizzes and things like that, but the students our students are not here in Western South Dakota. They're all over the place, and so they and it's different learning environments, different locations, and so you've just got to be flexible. Give them some more time, whether it's a day or half a day. You can set that up on your course management software to the accessibility. And also, they might submit things and then submit it wrong or do something. So don't close or don't close the Dropbox, but let them resubmit something if they figured something, or on the top of their head that something's wrong on there. And then on the quiz itself, you can I give unlimited submissions, so I just look at the most recent one that's there. Because things happen, they accidentally hit a button, or the power goes out, or they lose their internet connection. They don't want to be dinged because of that, because they're all working in quite challenging environments at the moment.
And then there's a couple of questions with the Zoom webcam approach about privacy concerns, and that some schools are getting negative feedback from students.
Yeah, I've kind of read that online. I think there was an article about that in the New York Times just recently that discussed privacy issues, and haven't seen that yet, but that's something if the students are really against it, I could certainly understand that. We're kind of making some difficult decisions here as we go forward, and if maybe it's the Respondus lockdown browser might work better for you, or the Respondus monitor might work. But yeah, it seems to me, I don't care what's going on in the background. Maybe they're sitting at their dining room table with their family running around, or their old high school bedroom with their trophies behind them. Whatever it is, I just kind of like to see what they're doing, and I'm more interested in what's on their desktop that's right there as they go through, so I can kind of see their logic and methodology that they're following along. So I'm going to try it. I'm going to talk to the students next week about trying to set this up and do a demo of it to make sure that it's worked. But yeah, I could certainly see there can be some privacy concerns with that as well. And if that's the case, then perhaps we're just going to have to do without and just have them, just trust the system.
So there's one follow-up question on the grading. Did you mean that it takes 2 hours to grade 30 exams, or 2 hours to grade one exam?
Oh, no, that'd be 30 exams. So usually I'll have the solutions or my solutions that are on one screen or part of one screen, and then I load everything on there. And so you got the solution there, you got your Excel spreadsheet with your grades all ready to go. For each problem, you'll put in, 1 through 9 or 1 through 5 or whatever it may be. And you just come up with a system, and you look at this student that's here and just enter the grades for that particular problem. A lot of times you can also annotate on there, so that would certainly take more time. If you've got a smaller class, and you can go onto your tablet computer, load the file, and then kind of put a check mark, and then minus, like you do like on a normal piece of paper. And you can save that, and then you can load that onto perhaps the Dropbox. There's a place where you can respond or load responses onto the individual Dropbox and take that file and put it on there. So then that might take 3 hours instead of 2 hours for a class of, let's say, 20 students. And that would be for everything. So again, it just depends on what the level of feedback you're going to provide. Maybe at a graduate level course, you're going to need to provide a lot more feedback, but you might have fewer students that are there. So you've got to kind of weigh what the time commitment is for that process.
Okay. Yeah, there's still lots of questions. I know, Ashton, I keep looking through them.
Yeah, and again, a lot were sort of repeat questions from different people asking similar things. So I think we have gotten to pretty much everything. If anyone has a few last minute questions, we can keep an eye on that. We do have about 5 minutes left.
So yeah, I see a question here on student surveys at the end of the semester. Have they identified cheating? Yeah, there's always going to be a handful that are going to just find a way to worm through things and cheat, but generally it hasn't really been an issue. I haven't seen my final course evaluations and whatnot hasn't really come up with the feedback that's there. I usually get a lot of positive feedback from the students of having that open book, open notes, or open computer that's there, so they can organize. And I tell them that right at the very beginning of the semester, that this is the way the exam is going to be administered, and so they can kind of start thinking about how they're going to perform on it, what they're going to do, and how they should save their materials. So yeah, it's kind of neat what they look through what they're sifting through as they go through the exams.
Some questions about whether you would try to use the same approach if you had a class of like 100 people.
Well, I've had a class of 80 people, and it seemed to work just fine. So it's just a big class. So this class here, where that's obviously he's not happy because he's got the blue screen, but this class had 80, maybe 85 students who were in it last spring, and it works just fine. It obviously takes longer to grade, and I do have a TA, a graduate teaching assistant that helps with. I grade the exams, and the TA grades a lot of the homework and other miscellaneous things we do in the class. So yeah, it takes a lot longer, but I'd personally like to teach much larger classes versus hold multiple sections of a small class. I think it's just a much more efficient way to do things, especially in light of increased research loads that a lot of us have. It's just a much better way to do it. So generally, yeah, it works well with large class. And even at Christchurch, New Zealand, I think I taught, not necessarily this way, but I did teach a class that had 120 students in it at one point.
Okay,
There
one
were
question.
also a couple questions.
Go ahead.
Yeah, you're reading the same one as me. If you think this would be feasible without the uniform notebook policy, if everyone sort of has very separate devices that they're using.
It could be, but it can be a challenge as well. I think I'm kind of blessed where I am that we have this policy. And, when students start bringing in their own computers, there's just issues with access, getting on the network, reliability. You might get this blue screen more frequently, viruses that are there. But it can work as long as you've got a mandate that a computer needs to be there. But then again, you're trying to balance those that have the needs of getting a computer and then perhaps those that don't. But the reality is we're all going to be on computers in our career. So what better way than to learn how to use it, to apply it, but in the classroom. So that's kind of been my philosophy. But I guess I haven't been somewhere that didn't have it, except when I did teach at the University of Canterbury. The students, once they saw how I was teaching in there, they did bring in their computers in that classroom as well. But for here, all our students, it's expected to have your computer ready to go and moving as in any classroom. And it's really up to the faculty members to kind of engage and use those computers in the classroom.
I think we're pretty much
we're
out
just
of time,
about,
right?
Yep, just about out of time. So again, I want to thank you, Jim, for the presentation today. That was wonderful. Thank you again to everyone who participated, who asked all of your great questions. There were a few people who I was going to follow up with after the webinar. And yeah, thank you so much for participating.
Thank you,
Ashley,
everybody.
you want to mention that there's the webinar next week, right? We'll send out information in the follow-up email.
Yes, so if you're interested in hearing more about access engineering, which Jim did show in a couple of his slides, there will be a webinar next week on that, and we will make sure that everyone gets the link to that. So if you're interested, you can sign up for that as well.
All right, thank you, and be safe.
Thank you, everyone.